So today we're going to be working on adding and subtracting, and this would be pretty common in about a second grade classroom. So we have a word problem right here. It says, there are 319 students from Texas Tech University at the library. The bus arrives at the library with 26 more students. How many students are at the library now? So what we're going to do is we're going to look for keywords in this word problem, such as more students arriving with 26 more students. So that right there tells us it's going to be an addition problem and not a subtraction problem. So what we're going to do is we're going to use the linear model to solve this problem. So right here I have a number line, and this number line is starting at 319. So we're starting with 319 because that's what how many students there are currently. It's usually better to start with the bigger number, because it's easier down the road when you're adding and whatnot. So in this situation, we're going to start with 319. And then we're going to add 26. And so we remember that from here to here, that's 10. So we know we can add 10. And so that puts us at 329. And from here to here, we can add another 10. That puts us at 339. So far we've added 10, and so 2 10s gives us a 20. So we need 6 more. So we can jump 1, 2, 3, 4, 5, 6, or half of this plus another one, because half is 1. So we added 6 right here, which would be 339, 340, 341, 342, 344, 345.
43. 44. I think that's where you got off.
Yeah. So we added 6, which put us at 340, gives us 1 more, and then 5 more plus that, 345. So that gives us 345 students at the library. Remember, sometimes a mistake can be looking and coloring in the blocks, not just the line. And if we're coloring in the blocks, that gives us area, and we want to make sure we only focus on the line. Now I'm going to give another way to solve this problem, as we all learn in different ways. So I have a set model right here with some manipulatives. So right here I have...
Okay, I'm going to stop you.
Oh, it's backwards.
It's backwards. Turn over one of your sheets.
I have my... Oh, okay.
Just turn one of those over.
Okay, so we have 3 flats, which gives us the 300. And we have, our number's 319, so that means we need 1 10 and 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this shows us the place values for the 319. And we need to add 26. Which would be 2 longs and 6 units. 1, 2, 3, 4, 6. So we're going to add 6 units to this. When we count that out, that gives us, we're going to try our best to make these ones into at least another long. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can change this out
Regroup.
We can regroup these ones for a long. And so that is, can regroup these ones for a long.
Okay, so regrouping 10 units for one long.
We're regrouping 10 units for one long. So we added 6, so we still need to add the 2 longs to the group because it's 26. So what we did was we added 6 ones and 2 longs, and then regrouped the ones into, we took 10 one units and regrouped it into a long. So now this is our solution. We have 3 flats, 4 longs, and 1, 2, 3, 4, 5 ones. So this is another way we can solve the problem.
So what is your number?
345. So right now we're going to work on elapsed time. And we need to remember that elapsed time is in base 60, not base 10. That's a common misconception. This is a problem that would be used in about 3rd grade, according to the vertical alignment chart. And I'm going to solve this 2 ways. I have the set model with the time tracker, and then I also have the linear model on graph paper, or to give us the number line.
Okay, that's area model. Set model is going to be groups using your counters.
Oh, so, but what was the one that we did today in class?
Let's stop this. Okay, you're good.
So we have a word problem here. It says, Sally goes to the mall. Her mom says that she will pick her up after 2 hours and 45 minutes. Sally arrived at 1:30 p.m. What time will she leave? So like I said, we have the linear model here to solve this first problem. And so we look and we see that PM, and we're going forward, so we don't have to worry about the conversion of PM to AM as we would around noon or midnight. So we're going to start right here on the number line at 1:30 p.m. We're going to make a jump of 30 minutes to make it 2 o'clock. So we only have 30 minutes, and we still have 2 hours, we have 2 hours and 45 minutes. So we're going to add an hour at this point. So that puts us at 3 o'clock. So right now we have an hour and a half. Remember, our end goal is 2 hours and 45 minutes. So we can add 1 more hour. And that puts us at 4 o'clock. So right now we have 2 hours and 30 minutes. So we're only missing 15 minutes as we need 2 hours and 45 minutes. So we can add 15 more minutes to this. And that puts us at 4:15 p.m. So her mother will be picking her up at 4:15 p.m. And we can double check our work by seeing that this is 1 hour plus another hour is 2 hours plus 30 minutes is 2 hours and 30 minutes plus 15 minutes is 2 hours and 45 minutes. Another way we can solve this problem is using our time tracker. So right here, we know that her mom dropped her off at 1:30. And that's our start time. So we have our hours, our minutes, and then our time tracker, or what's happening. So we're going to add 30 minutes here. We're going to add 30 minutes here. And so that makes it 2 o'clock. This gives us a 2 o'clock being an even ground to add from. So now we're going to add an hour. And that puts us at 3 o'clock. We're all still in PM because we started at PM and we haven't made it till midnight yet. So now we're going to add another hour because we only have 1 hour and 30 minutes. That puts us at 4 o'clock. So now let's check over here in the time tracker how much time we've added so far. We've added 30 minutes, an hour, and an hour. So that's 2 hours and 30 minutes. And remember, we were adding 2 hours and 45 minutes. So we need just 15 more minutes to add. So we don't need to add any hours. All we need to do is add some minutes. And that puts us at 4:15 p.m. or our end time. And at 4:15 p.m., her mom will pick her up from the mall.